Good morning, good afternoon, good evening, everyone. Thank you for joining us today. Welcome to this webinar, part of the ongoing series hosted by ISO Technical Committee 347, Data-Driven Agri-Food Systems, as part of our commitment to transparency, engagement, and inclusive participation in the standards development process. ISO TC 347 is a relatively new and ambitious committee working to develop international standards that enable trustworthy, inclusive, and effective use of data across agri-food systems. My name is Andres Ferreira. I'm the chair of TC 347, and I'll be your moderator for today's session. Our webinar series is designed to explore key technical areas where standardization can support innovation, sustainability, and interoperability in agri-food systems. Today's topic, EU legislation is quietly reshaping agri-food data interoperability and what data spaces have to do with it. It relates to the convergence of data ethics, data interoperability, the provision of data services, and legislation. This is a critical area where shared standards can help connect diverse actors from farmers and researchers to technology providers and policymakers. Yet our understanding of the nature and scope of these standards and the forces driving them is still incomplete and evolving, hence the need for discussions like the one we'll have here today. In this webinar, we aim to review motivations for standardization in the agri-food systems data interoperability domain, define data spaces and show their relation to this topic, describe recent and upcoming European legislation and explain why it will be influential in this space, highlight how this regulatory perspective on data spaces connects to standardization opportunities, and show how you can actively participate in shaping upcoming international standards in this space. Now let me introduce our speaker, because we're very fortunate to be joined today for the second time in our webinar series by Dr. Christian Hennig. He is the CEO of Permarobotics, also the chair of Germany's Mirror Committee for TC 347, and also the convener of our ad hoc group 5 on annotating agri-food systems data for use with AI. He originally studied medicine, worked as a pediatrician, and conducted intensive research on allergies, autoimmune diseases, and how environmental factors affect human health. At 25, he founded his first biotech company, and by today, he's already launched 6 firms in the biotech and agtech sectors. His focus is always on digitalization and automation. He holds more than 30 patent applications and continues to seek innovative solutions for resource-efficient agriculture that can balance food security with the preservation of our planet's life support systems. He's been programming since the age of 14, and that's his preferred form of expression. His vision is a standardized, open Android for agriculture that will allow new forward-looking products to be built on top of it. To realize this, he leads the German delegation in ISO TC 347, as I mentioned earlier, and is an active member of the Linux Foundation's AgStack initiative. In 2025, he was honored as one of Germany's top 30 changemakers in agri-food. With that, I will now hand things over to Dr. Christian Hennig to begin his presentation. Christian, the floor is yours.
Thank you, Andres, very much for this kind introduction. Let's just move into the space of law, because our standardization work is never existing in an empty space. We have to look at what the law is telling us, what the people in other fields of standardization do, and therefore I'm happy today to lead you through the many EU laws that we now see that are shaping revolution in AI, the revolution in data, and also the revolution in reshaping agriculture into a more sustainable way. And to kick it off, we will go to a completely different field. It's railways. And railway started in Germany in the 19th century. And if you look at this, this was a real success factor, maybe the biggest success factor of the economic boom that took place in Germany between 1850 and 900. And the railway was the public infrastructure. So it was an infrastructure that made it possible that people could move from the land into the cities, that companies opened up in the smaller cities, transportation of energy, sources like coal, goods, and so on. So having a public infrastructure that everybody could use opened up many possibilities in Germany. These almost endless economical possibilities brought some problems, some unexpected problems. One of them was that until the 1890s, we had no uniform time zone in Germany. So it was always noon when the sun was highest. So there was difference between the eastern parts and the western parts of Germany in the 19th century, and that made it impossible to have a timetable for the trains. And so they had to generate laws that made interoperability, or data or goods transfer possible. So there was a number of laws that have been generated in the late 19th century that made infrastructure possible. They needed legislation and standardization in having uniform time, uniform track gauges, uniform signals, uniform custom areas. So we had in Germany more than 20 custom borders when you have been shipping your goods from the northern to the southern parts. So we had to change this. And the laws, the legislation helped us to change things. So wrapping it up, it was not the steam engine or the fancy idea to put a steam engine on wheels that changed things. It was only the enabler. The railway network, so the infrastructure, was the breakthrough in Germany. And scaling it up was only possible through legislation and standardization. Otherwise, you would only have small pieces of trams and railways somewhere and no connection between the lines. Setting up a standardized public infrastructure was the success factor for economic growth in Germany in the late 19th century. And when we look at today, it looks quite similar. Today, we have a lot of, let's say, steam engines or locomotives. So we have AI, we have IoT sensor networks, we have robots, but somehow they are all not interconnected. So the steam machines are like the software, the IoT, the robots, the AI. But as we have no standardized, no public digital infrastructure, we have these fragmented data landscape that everyone is talking about. Our common misconception in the former, let's see, 10, 20 years was if we just have more data, so big data was the big buzzword, we have better decisions. So we have now lots of data from different sources. We have satellite data, we have drone data, we have soil sensor data, and we have a lot of good software, many digital solutions, but we have little integration, we have little comparability. So a data without infrastructure, you can just look at this like a vehicle without roads or rails. So in Germany, at least in Germany, the digital reality in 2026 is that one farmer has 20, 30 apps for the weather, for the market forecast, for soil sampling data, for farm management, and so on. And all the data live in silos. There are only proprietary platforms, very few interoperability. So you have media breaks, you have upload data, download data, transfer data. And if you want to integrate things into each other, it's difficult because there are high integration costs and most people refrain from taking those high costs. Yeah, and so EU said we need laws to force a solution that integrates data, that makes data interoperable, that allows exchange of data, tracing of data. And this is called digital public infrastructure. And part of these digital public infrastructures are data spaces, which we will talk about later. Such digital public infrastructures, like the railways in the 19th centuries, they are neutral, they need to be open, they need to be heavily standardized, and they need to be sustainable in the long term. So the key point here is that innovation arises on infrastructure, not instead of infrastructure. So what we missed all the years is the digital infrastructure, and we now need to build it worldwide. And the EU legal frameworks that are shaping those digital public infrastructure and force data interoperability can be looked from many angles. I will look at them from the agricultural perspective because that's what we do here at ISO TC 347. So there are many stakeholders that need those frameworks. There are the farmers, there are the scientists, there are the legal guys, there are the technology providers. And they all need reliable data, secure data. They want to use AI. They want to have trusted data spaces. So a lot of things that need to come together to help the people to have those data spaces and infrastructure. So let's start the part with the non-sectoral EU laws. So these are laws that are not really related to agriculture, but they are influencing it very much. And there's a huge number of acts that you released over the last years. I will only touch the most important ones. And on the second part, I will look at the sectoral EU laws like the EUDR, for instance, that are influencing directly agriculture or the agri-food chain. So maybe the most common one is the Common Agricultural Policy, which I will not touch. The European Deforestation Regulation, carbon farming and carbon removal legislation, nature restoration law, animal health law. So there are a lot of laws that are influencing how data is generated, stored, transferred, given to the AI that is agri-food specific. So let's start with the non-sectoral EU laws. And I will not deep dive into each single law. If you are interested, you can just take a photo of the QR code and it will directly bring you to the respective law of the European Union. So the first is the EU Data Act, and the EU Data Act, most of people in the agricultural space have already been confronted with because it basically says the farmer or the data generator, the generator of the raw data, owns the data. So it makes clear who is owning data and who has access to the data. So the one that generates the data, machine generated data, have to have access to the data. And the aim of the EU was to prevent vendor lock-in so that farm management systems in the future can access machine data, for instance, from tractors, from other machines that have been generated, or even from sensors in the field. So this is what the EU Data Act is standing for. It's not farmer specific, but it has a lot of impact on the agri-food scene. In the first paragraphs, I'm always stating what the impact of the law is. And in the second paragraph, I'm stating what the relevance for the agri-food sector is. So this is the EU Data Act, telling people who owns data. The second one is the Data Governance Act. And this is really important for the infrastructure because it creates a framework for data trustees, data donation, data collaborations, data exchange. It enables legally compliant data sharing. So if you just own data, you can do anything with your data. You need to share it. And you need to make sure that this sharing is somehow safe, secure. And you want to offer maybe your data that other companies, other partners can take the data and make sense out of the data. And all of this is somehow regulated in the Data Governance Act of the EU. Then there's Open Data Directive, which says that the public bodies have to provide high quality data sets. That's really interesting because we, in the agri-food scene, we are relying on those public data that we can get, like weather data, satellite data, environmental data, because we need to feed it, for instance, into AI models or other data-driven services. So it is important for us that those data sets are available. However, I have to say, what means available? Yeah, if you just can download as a PDF, you cannot just give it, or even today you could give the PDF to an AI, but in a standardized real digital format, it would be much better to have GeoJSONs, for instance, or other data set models that we can use directly. But this is Open Data Directive. The next is Digital Services Act, which is, I guess, a little bit less important, but it says if you are offering services, you need to make this transparent. How your algorithms are generating those recommendations, which might be needed for marketplaces, platforms, and consulting tools. It covers rules for online platforms, transparency, content, and liability. The AI Act is handling everything around AI. So if you're using AI for your business, you have to declare the risk level of the AI. So if the AI is somehow influencing the real life of real humans, just to say it in simple words, it's a high risk. If you are just generating nice looking images of a plant, it's not a high risk. So AI Act tries to group the risk that AI has on our real life into groups. And if it is a higher risk AI usage, then you have to have special security measures to do this, or you are not allowed to do it at all. So AI Act is very important for all people that are using AI models for business in the European Union. The next one, and that's one that I think will be very relevant in the very near future for all of us, is EIDAS 2.0. Because, as we will see when we talk about the data spaces later, you need to make sure that the identity of the participants is real, is the one that is there. Yeah? So if you are selling your data to a company XYZ, you want to be sure that this is really a company XYZ and not somebody else sitting somewhere and making nonsense with your data or misusing your data. So you need a digital identity for humans, so for natural persons, and also for legal persons. And this is what EIDAS 2.0 does. It introduces a European digital identity for each human in the European Union, which will start, I guess, this year or next year. I guess it's this year already. So there will be a EUDI wallet for any natural person, and there will be a European business wallet for legal persons. So if you have a company, then it will get a European business wallet, and you can use this business wallet in, for instance, data spaces to claim your digital identity. And this makes stuff much easier. So talking about data spaces, it's easier for a buyer of information when he knows that the person that offers it has a digital identity based on EIDAS 2.0 compared to just an email address, whatever. Yeah. So this is what EIDAS 2.0 is about. And it's, as it's said in the last line, it's a central base for trusted data spaces. It's extremely important. This one is just generating a lot of headaches for companies. So it's the Corporate Sustainability Reporting Directive. It says that you have to have digital sustainability reports, and companies are paying a lot of money at the moment to collect data along supply chains and generate those reports. It's an enabling law, but because it forces data spaces and data interoperability. So I guess it's a lot of headache, but it's also good in the long term because it shapes the digital infrastructure. Because people need now digital infrastructure to solve the problem. And the last one is EU taxonomy that I want to talk about. It's a definition of sustainable economic activities, and it's needed for reliable digital documentation. So it's like a basis of the integration of all the field and farm data in the future. So a lot of people in the agricultural field are at the moment talking about EU taxonomy. So those have been the non-sectoral EU laws that are influencing the agri-food sector and the digital infrastructure generation. And now to the sectoral EU laws, just a selection of them, because they are really also generating a lot of headache in solving the tasks. So one of them, and I will give you an example later, is EUDR, so the European Deforestation Regulation, which says you have to trace on the parcel level, on the field level, where your coffee, for instance, is coming from. So if you want to import coffee to the EU, you have to prove that it has been grown deforestation-free. So that already tells you need to make sure that on your plot in, for instance, Honduras, Vietnam, Guatemala, there in the last 5 years have been no trees cut. So the coffee is growing under the canopy, for instance. So you need a lot of geodata. So you need to know where each plot is. You need to make sure you are tracing the coffee from the plot to the EU border. And there are many partners that are involved in this process. So you need a lot of data interoperability, data exchange, and data spaces. Yeah, that's EUDR is one of the main drivers of data space generation in agri-food. However, it's really difficult to get things working, and therefore it was already postponed 2 times. So we will see what happens now. The EU is now financing projects to get EUDR working in the producer countries. So there's a lot of pressure at the moment on EUDR. Carbon removal certification framework, or now it's called carbon removal and carbon farming framework, is something that is basically not only telling farmers to trace stuff, but it's giving money to the farmers if they can prove that they helped harvesting carbon dioxide from the air and pushing it into the soil or wood or anything that can store carbon. So this one is very actively worked on. We will have the next summit in Padua this spring, and it's already in place, the law, and now the implementation takes place. So there will be frameworks and methodologies published by the European Union, how you have to report the CO2 harvesting with agricultural practices. And therefore, it's mandatory to have a digital MRV process. So you have to measure, to report, and to verify stuff, which basically means you need data spaces because you will have many partners. You have the farmers, you have the satellite data providers, you have the maybe soil monitoring companies, you have the certification company that needs to do the verification. So all of them need to work on the data that you later upload to the EU. The EU will have a buyers club called Buyers Club for the carbon certificate. So it will buy it once you adhere to the CRCF framework, and then you will get, as a farmer or as a project provider, get money for your CO2 removals. But all of this needs digital public infrastructure to be scalable. Next one is nature restoration law, which is the newest one. But basically what it will do, it will generate legally relevant data objects out of landscapes. And it will ask for monitoring those ecosystems and see how from a baseline the progress is restoring the nature over the next decades, which only will work if you have a digital public infrastructure. And then it's also a quite new one from last year is the soil monitoring law, which is also interacting with the nature restoration law. So soils become standardized long-term monitored data objects, and they need to be monitored by different data sources like sensors, soil monitoring labs, models, satellite data, and so on. And again, we need the digital public infrastructure to connect all those sources to each other to enable monitoring and reporting based on the soil monitoring law. So a lot of laws you have seen that's really taking place over the last 2-3 years, I would say, and which tells you we need those data spaces because otherwise it's really difficult to implement all of those laws in a way that you have a simple way for interaction for the different partners, scalability, independence of vendors, single vendors or no vendor login. So data spaces need to happen now, and they will happen now. So let's have a look. What are data spaces? That's one of, I guess, one of the buzzwords in 2026. Basically, they are empty. There is nothing in there. But they are made of hardware and they are made of software, and they have so-called rule books that make sure that anyone that is participating as a so-called provider of data or consumer of data with a fixed set of rules that all the participants in the data space must agree on. And the data space as a software is only monitoring that everyone is compliant with those rules, so that the providers and the consumers are doing what they are intended to do, that they are only using the data for the proposed goal or the proposed process. And that's what the data space does. It can also handle mediation tasks. So if somebody does something wrong, it's monitoring what happened, and it's mediating problems. It can function as a marketplace. So all those data providers and also service providers, they have so-called connectors, and those connectors are able to promote what is offered on different levels. Yeah, whatever the provider wants to show to the outside, it can says what is available here on this, let's say, marketplace, and what do I offer? What can you buy, or what can you use from me? And that's a very cool and important feature. You can provide a so-called trusted execution environment that says that you can, if you don't want to give the data to the consumer because you are not sure what the consumer else will do with your data, but you need the algorithm of the consumer. You can say, okay, the algorithm can take place inside the data space. So the data will never leave the data space, but the result will leave the data space towards the consumer. And that's a quite cool way to do it, to have an additional trusted environment. And so all of this stuff of the data spaces are reflecting the EU laws we just talked about. And there is an International Data Space Association, which is drafting at the moment standards, which we will have a look later, to have this in a standardized way. So, but as I said, what they are not data silos. They are not central data repositories. Basically, there is no data inside the data spaces. The data stays with the owners. So data sovereignty is preserved by using those data spaces. And that's what people want. Data spaces are already active anywhere in the world. It's a really, really very active process at the moment. So we have India stack, which serve 1.3 billion people, 10 billion payment transactions per day, and the China stack, which serves about 1.4 billion people. So these digital public infrastructures, similar to the railways in the 19th centuries, are paving the way for good business, but also for good environmental monitoring. So it's the enabler of this century, I would say. So data spaces and digital public infrastructure. For those that are not familiar with these terms, I have a very short wrap up what those digital public infrastructures have to consist of. So there are non-agri-food specific components. First one, as I told you when we talked about AIDAS, is the identity and access management. So we need to know who is who and who has rights to do stuff. Then we need the data spaces that are managing the transfer between the partners, setting the rules between the partners. And if you have business to do, then you need payment structures to not only the data is running between the partners, but also the money. And that's it. So more or less, the digital public infrastructure is designed not for the agri-food sector, but the agri-food sector needs it. And what agri-food needs to do now is to have connectors to those standard components on the left. And it needs good agri-food semantics and mappers. Because what I can tell you from our everyday's work, if you have a nice data space and offer stuff, but nobody understands the stuff, there's no business. Yeah? So you need interoperability on the level of semantics. At least you need mappers that can transform the different data sources into the other data source. So if you have your field boundaries as a shapefile and the other end there's only people that understand GeoJSON, it's a problem. You know? Somehow you need to map it. Or if you have different geo coordinate like VSG84 and some other coordinate systems, they are just not matching to each other. So you need mappers, or you need to agree on standardized semantics for the agri-food sector. Otherwise, data spaces will be empty, so stay empty. I brought just one example from our daily work, which we donated to Linux Foundation. It's called Trace Food Chain, which makes clear what the reality looks like. So we are just about to build a DPI for the Honduran coffee industry, and it already serves as a EUDR tracer for Honduran coffee growers. So you need to onboard the coffee growers, you need to onboard the buyers, the transporters, the mills, different managers. You need to collect the field boundaries. You need to collect the data of the harvested coffee, the quality. You need to digitally sign all the processes so it's legally binding. And then you can trace the coffee from the Honduran rainforest to the EU border. And as you can see on the right, there are already partners like insurances, financial partners, institutions that want to be part of this data space, because once it's there, like for EUDR, you can see, okay, I can do different other things if there are the partners on board on this marketplace or in this data space that offer, can consume, can process data. That's a really good example, success story of data spaces in the agri-food sector and what they can do. And that's the last part of my talk. We have seen, okay, there are a lot of EU law that forces data interoperability, data spaces, data safety, and forces infrastructure to being constructed in a digital way. And this will foster business. So it's good news that all of this happens now. However, those digital public infrastructures need standardization, and that's our work. We are a small part of this work because we are only looking at the agri-food sector, but it's important that we do this on the agri-food sector. And if there are no standards, there will be no standard spaces. So that's like building the Babylon Tower. Yeah, so that at the end of the day, nobody understands each other and you cannot finish your beautiful tower. So the problems are if there are only individual contracts between 2 partners, 3 partners, there is no scaling, no automated scaling. So if you have just APIs to talk to software systems, there is no trust. And if semantics is lacking, nobody can understand each other. International standards is one of the really needed foundations to build the data infrastructure. And therefore, there is already a lot of initiatives. So ISO IEC JTC1 is, together with the International Data Space Association, submitting drafting standards for the standard part or the non-sectoral part of data spaces. So there is a standard submitted for data space concepts and characteristics, for the data space protocol, and for the decentralized claims protocol. And there is a sectoral standardization in the agri-food data spaces led by ISO TC 347. So that's in a nutshell what happens outside our standardization work with laws and with digital infrastructure construction. My take-home messages are that data need infrastructure, that infrastructure needs standards and laws, that standard and laws enable innovation, that the data spaces are public enablers. So we will see a lot of business run on data spaces. I can tell you that also the EU, United Nations, UNECE is working on this at the moment. And we are building the infrastructure of tomorrow's world now. So it's important to get involved because the stuff that we create in this 10 years will have a big influence on the future of us and also on the future of AI taking slowly over many tasks. So the question is not whether we want data-driven agriculture. We have to ask who will build the infrastructure for it and how can we participate. And so our call of action or our idea is, if it would be interesting to have an ad hoc group on data spaces at T347 to help us to align the work of TC347 with the legal framework of the EU for data interoperability and to align our work with the one of ISO IEC JTC1 for data spaces. And with this, I'm handing over and back to Anders.
Thank you, Christian. That was a fantastic set of ideas there. A lot of information. Thank you for including those QR codes for reference. To wrap the presentation up before the questions, if you ask yourself, how can you work on this? Some good news, most of the work happens online. We meet in person only once a year for an in-person plenary. Everything else is done virtually. Most of the work is done in smaller groups, ad hoc groups, advisory groups, and starting soon, working groups. They meet more often, like I said, but they set their own schedule. Regarding participation, primarily, you can participate through your national standards body that sets up what's called a National Mirror Committee. If you're interested in this and you don't know who to talk to in your country, reach out to me. Another possibility is through a liaison organization. So if you look at our website in the main ISO page shown there at the bottom, and I'll put those in the chat during our Q&A session. You'll see 10 liaison organizations we have right now. If you're a member of one of them, you might be able to participate through them, though you don't get to vote. You get to work in the working groups and so forth and make comments on everything, but you don't get to vote. Last but not least, if you have any questions, contact us. We have an email address. We have a LinkedIn page where we share information. We have a YouTube channel where we put these webinars, and we have that page. Now let's transition to some questions, right? First thing we've got is a comment from Einar here, Vastveit, saying, I think it is important that the farmer own the aggregated data and not the raw data. Okay. I pointed out that some folks think the opposite, right? Or that he'll get different degrees of pushback depending on what categories of data it is that are involved. So what do you think about that statement? Farmers owning the aggregated data, but not the raw data. The raw data may be belonging to the machinery companies. What have you seen in the regulatory space, and what do you think from your perspective?
Yeah, the regulatory space clearly only talks about raw data. The problem is, what is raw data? Is it the millivolt that is coming down out of the soil sensor, or is it already, because after this millivoltage output of the sensor, there is already an algorithm generating the soil moisture out of it that is displayed to you. So it's difficult really to find, is there any raw data that anyone can make sense out of it? And furthermore, normally you are not storing the raw data on your own smartphone or PC as a farmer. You often are not the real provider in terms of data space. You are a sub-provider because you have a farm management system maybe that takes your data and cares for it. However, all of this stuff can be done with contracts. And I would really see a task of future farm management systems, data spaces, whatever, in contracting with the farmer. So, my dear farmer, I need your raw data to make business. I'm paying you this money for your data. What you will get back is this and this and that. Not only money, maybe, but also aggregated data. And you are the owner of this aggregated data. For this, I need whatever. So there are a lot of contracts will take place between raw data, intermediate data, final data providers, consumers, processors, and so on. So this is stuff that is really needs to be handled by the data space. We are seeing this at the moment. And we are asking farmers, how sensitive is it for you to sell data? Because giving it away for free is maybe stupid. Yeah? So you can sell your data, but you need to make sure that the data is only used for certain intentions. That's what data spaces make sure. And then maybe you are saying, okay, I'm paying for the processing, but I want to process data back and store it being me as the owner. And that's something I guess it would really work, because then farmers are really willing to share data for certain things. And but from a legal point of view, it clearly says Data Act, it's only about the raw data at the moment.
And I think your point about trying to establish some clarity on what we're talking about when we say raw data is a very good one, because machinery manufacturers, for example, will tell you that some of the raw data that is going through their controller area network before it goes through the calibrations and multi-point calibration curves and so forth is essentially useless, right? And as the equipment becomes more and more complex, the amount of conditioning and calibration that some of the raw data have to go through before it turns into something actionable is very significant. So that is a tricky business right there. Let's see another comment. So Marwa brought up, how can we balance the farmer's rights with the industry's need for raw data to develop better ag tech solutions, right? And then Einar also pointed out that depends on who leads the innovation, right? Do we want the tractor and input companies to lead? Any thoughts about those balancing acts?
Yeah, as I said, we need these digital contracts that more or less will take place automatically. We see this now in Honduras. Yeah, The farmers want something from the financial industry. The financial industry wants to access to the smallholder farmers. So there is a need from both sides. And if there is a need from both sides, there is a deal, there is business. And it needs contracts. So if there is no need for a deal, there will be no balancing. So the farmers need those deals, but often they are too small, as I said. And so we need, advocate is the wrong word. Yeah? We need businesses that are more on the side of the farmers, that are clustering those farmers as providers, as we call them in the data space. So the farmers will be sub-providers. They have legal contracts with the providers, and those bigger providers, like farm management systems maybe, they will take part in the data space and then do business maybe with the machinery provider. So that's how I think it will happen. And it could be that we do this just now in Germany with one of the models that we are generating for German farmer association interplay with industry, that those providers could be or have to be trusted entities for the farmers. So they should be advocates for the farmers, but doing business for and with the farmers. And that's something that is shaping right now. It's totally new and will be enabled due to the data spaces. And I'm quite optimistic that this will work long term. But then, therefore, we need this legal backbones and the standards backbone. Otherwise, anyone will do something different and it will not work together. And again, the United Nations are working on this too. They have this UNTP, United Nations Transparency Protocol, that will make such processes transparent along the agri-food chains.
There's three questions or comments here that are very relevant. One is from Thomas Klingstrom, going back to the matter of what's raw data, where he says, a tricky issue is that the algorithm for converting the genuine raw data, like an electrical signal, into actionable data generated by the machine may be the most sensitive part of the business, right? It's their secret sauce where a lot of the innovation actually happens. So an equipment manufacturer may be willing to share raw, useless data or the first level results, for example, an amount of cells in a sample, but not both. And so that defining what needs to happen in a way that doesn't stifle innovation, but also doesn't cheat the spirit of the law is a very important point. Lena says, I'm researching data spaces, and one challenge is what standards should be used to represent the data, right? So regarding metadata, she points out that DCAT3 has been chosen to describe that, but the actual data is probably still open. She says, for example, is Inspire suitable for describing soil samples? I'll jump in real quick here saying that the semantics, how to represent the meaning of complex things like observations and measurements are a big part of what TC 347 is trying to do. Soil is a good example of that. Look at the work that Ad Hoc Group 2 has been doing. That's our upcoming Working Group 1, hopefully, regarding reference data for things like crops and the field operations and pests, and the work that ISO 7673 Part 2 in our sister committee on agricultural electronics, Technical Committee 23, Subcommittee 19, has also been doing. Christian, any comments from you?
Yeah, that's one of the headaches of data spaces, that they are not caring about semantics at all. So once the partner have a digital contract or are agreeing on sharing data, the content doesn't matter. It even in standard ways doesn't travel the data space at all. And so this semantic stuff, as you pointed out, is more in this standardization body for the agri-food in our TC. Will take place here. However, and this is also work done by Andres and Johannes Lehmann in the special advisory group before kicking off TC 347, is looking at the landscape of agri-food semantics. And it turns out that we have 600 different agri-food languages, so standards to describe data. And it's highly unlikely that even if we have an ISO standard on semantics, everyone will throw away working standard for its software solution, whatever. So what we will need is we need mapping services. So somehow we have this standardized semantics of ISO-TC, for instance, and then we need to map on the fly maybe the data to each other to make the data exchange possible.
Yes, absolutely. And another comment from Marwa, since data spaces function as a marketplace, how does the rule book of the marketplace ensure a level playing field between large corporations and smaller participants?
So there is an inside and an outside of a data space. So once you sign the rule book and you are in, everyone has to adhere to the rule book. And in a public rule book, a public data space, the rule book is open. So that's the idea behind it. If you have a sectoral data space, then the partners agree on it and nobody will know what's inside happening. And part of those data spaces based on the rule books are so-called connectors. So each participant has to have a connector to the data space. And inside this connector, it's a piece of software, there is the catalog. And the catalog has the offerings that the participant has. If it's a data provider, you will see the data that is provided. If it's a service provider, there will be a description of the service. However, and that may refer to your question, what do you want to expose to the partners inside and outside the data space? So is there a certain quality of your data points? Is there a geolocation or a time constraint attached to your data point? And that's just what we are actively working on. If you have people outside the market hall, you also want to show them what you have to offer, but maybe on a lower granularity to tease them to join the data space. So you want to tell them, I have soil samples, 10,000 soil samples, but you cannot see where exactly they are, but they are dispersed over 200 square kilometers in a location in Vietnam. And then the next step is negotiating. Yeah? So should I go into the data space? Once you're on the data space, you can negotiate how to access the exact geolocation and what amount of money you want to pay to have access to, or what service do I offer? Can I offer the service if the quality of the data point is too low? So all of this stuff is what we are managing in those data space connectors. That is quite special in the agricultural space compared to other industries.
So Marwa says that she's interested in using data spaces in her proposal about food waste, right? And I'm pointing out that food waste is something that we're very interested in, and we want to enable comprehensive food loss and waste management through data. ISO has another group, Technical Committee 34, Subcommittee 20 on food loss and waste. We are in very active conversations with them and have joined some of their projects on, for example, a management system standard for food loss and waste and a standard called ISO 20008 on management and measurement methods for food loss and waste. That's in our strategic objectives, in fact. So if you're interested in the data aspects of that, Marwa, you're in the right place. We're at time here. So thank you all very much. Reach out to us, please. Thank you, Christian, for your excellent presentation. Thank you all for your great questions. Have a wonderful rest of your day. Thank you.
Bye-bye.